Tension.
Potential.
Oh, potential. Yeah, but in your relevant standard, right?
Yeah.
In work, energy, and power, you studied this work, and this work was related with what?
Energy.
Energy. Yes, again, it's correct. But the main cause of this work done was the external force, right?
Yeah.
So work done is related with force, and then force is related with all the other things. That's why work is related with all those things, right? So if we write work done, right? This is, and I'm talking about external work done, right? So this would be, this is dependent upon force, right? Now, there can be different kinds of force, right? So this force can be uniform. This force can be variable, right? So for different kinds of force, let's say for uniform force, work done would be simply what? That would be simply F dot ds or Fs. Right, this is for uniform force, right? Right, and what is uniform force? Uniform force is Uniform force is something like 3I plus 2J plus 5K, something like that. Right? This is uniform force. It is not varying with X, Y, Z. So this is a uniform force, and for uniform force, this is your work done. Right? And for the variable force, this thing is how much? This is simply F dot ds integral. Right, and if I write from initial to final point, so yeah, this is from 1 to 2 or R1 to R2. Right. This is for variable force. And now we know that this is, if I write external, so this would be external, external, and external. Yeah, hello Siddhika, Assalamu alaikum. Yeah, so we have just started and we're talking about this work done in external electric field. Now, we know that how this force is related with electric field. How this force is related with electric field? How this force is,
QE.
yeah. So this is electric force, right? That is QE. And if I write the external force, because if we want to do some work, then we have to apply the same force, but in the opposite direction. So F external is minus of Fe, which is minus of QE, right? So we put this thing and then we can write this work done, right? Work done. Let me simply write. So work done would be minus, or again, we have two kinds of this thing. So that would be, let's say, from initial final, that is minus QE and dot R final minus R initial. Right. So this is for uniform electric field. And for non-uniform, for variable electric field, work done would be minus of QE dot dr and then R initial to R final. Right. So that is the work done, right, in terms of this electric field. Is it clear, guys?
Yes, sir.
Yeah. Please note this one down, and you have done a simple question, so you'll do a complicated question using this thing. Please note this thing down, and then you'll do a question. Yeah, please note it down. Read it. Yeah, whenever you guys have noted, please tell. Yes, whenever you guys have noted, just tell me, right? Yeah, noted everyone.
No,
Yeah. Okay.
no,
So,
not done.
okay, okay. Sorry.
Done.
Yeah, good. Now let us do the different kinds of question using this thing. So we have this question, right? So let me erase this. Right. So we have 3 points, the O, P, and Q, right? And we are bringing this charge from here to here, O to P, and then P to Q, and then Q to A. And this is how the electric field is varying. Because you guys have done, right, you guys have already done, let's say I gave you E equals to 3I plus 2J plus 4K. And then in this electric field, you are taking a charge from, let's say, R, that is 2I plus 4J to, let's say, P, or let's say P point, and then Q point, which is 3 comma 2 comma 5. Right, so these kind of questions you guys have already done. So we just calculate this thing as minus Q E and dot R final minus R initial. So in this case, this would be RQ minus RP. So these kind of questions you guys have done. So we'll not do this, but we'll do the variable, right? Now, this work done is in 2 dimension, right? So we know that what kind of electric field is this one? What kind of electric field is this one? Variable or uniform? Oh, I have already written in the, yeah. What kind of electric field is this one, guys? Yes. This electric field, what kind of electric field is this one?
Variable.
Variable, right? So then the work done would be minus QE dot dr, right? And then R initial to R final. So that would be the work, right? Now, we know that this dr, because we are moving in 2 dimensions, so this dr or dl, right? This dr would be dx I hat and then dy j hat. So this would be dr, right? And electric field is already given. Electric field is already given. We know all these points. So if I calculate work done from O to P, right? So that would be how much? That would be minus Q and then E dot dr, right? And then this would be simply how much? So this would be, we are going from O to P, right? This is the work done, right, guys? Is it
Yes,
clear?
sir.
Now, can you guys tell me that we have dx and dy, but for this case, what part would be 0? In OP, what part would be 0 in this case?
Divide.
Dy, yeah. Dy is 0, so then dr is simply dxi. Electric field we already know, right? Electric field we already know, so we put that value. Q value is also given, minus 10 microcoulomb. So we'll put that value later. But this is O to P, and then this is x plus 2y I hat, and then plus, and then plus 2xj hat, right? And this whole thing with dot product of dx I hat only, right? So only this I hat part will survive, j part will be 0, and we are left with q 0 to p and x plus 2y and then dx, right? So this is the integral. Now, if we look at this dx, right? So from where it is going? Dx is going from where to where? Yeah, how dx is evolving? Yes. How dx is evolving? From 0 to 2, right? It is going from
Yes.
0 to 2. So, so then we can write this thing as minus q. And if you look at this thing, right? So if I write y in terms of this thing, this is a straight line, right? In this case, y is 0. So I can cancel this y part, right? In this case, y is 0, right? From O to P, there is no y, right, guys? So this would be
Yes.
simple x dx. And what is the limit? This is 0 to 2 x dx. So this would be simply minus q is minus 10 microcoulomb. And then this integral is x squared by 2. And from 2 to 0, right? So how much would be this thing? So this is 10 microcoulomb. And then this is x square, so 2 square. And what is the unit? Is it in centimeter or meter? Okay, so let's say that this is, all these are in meters. So this is 2 square. We take out this 2 outside. And then this is 2 square minus z square. So only 2 square. So this is 5 and then 4. So 20 and micro, that is 10 to the power minus 6 and joules. So this is work done from O to P. Is it clear, guys?
So,
Is it clear?
yeah.
And now we calculate from P to Q, right? We calculate from P to Q, then what would be, so work done from P to Q, that would be minus Q, and P to Q, T dot, now in this case, we are going in Y only. So this would be, let's say dr, right? And in this case, dr would be simply dyj. So we put that value, right? Minus Q and P to Q, right? E is how much? That is x plus 2y plus 2xj. And then dot dyj. So again, this j and j will survive. And how much do we have? X, P to Q, right? And this is 2x dy. Now, these are two different functions, right? But if we look at this diagram, right, what can you say about x? What can you say about x, guys? Yeah. In this diagram, from P to Q, what can you say about x? Yes. Yes, guys, what can we say about x? X is 2, right?
Yes.
So we can just put that value. X is 2. And this is 4. So 4 is taken outside and this is only dy. So from where it is varying? What is the limit? It is from 0 to 2 again, right? So from 0 to 2, and this is dy. So this would be simply y minus 4q, and y limit is 0 to 2. So this would be how much? Minus 4, and q is minus 10 microcoulomb, and then this is 2. So this is how much? 80 and 10 to the power minus 6 joules. Clear, guys? Clear?
Yes.
Now we have this difficult one, right? So let me just, in this case, I will, so we are going from here to, we're going from here to here, right? This is P and OP, right? 0, comma 0, 2, comma 0, right? And in the next case, we are going from, oh, so we are going from here to here, right? P to Q, and then this is 2, comma 0 to 2, comma 2. Now, this is the interesting part, right? From Q to O, right? So Q to O, Q to O we are going. Okay. Now, we have this situation. So we are going from here to here, right? And this is what? This is 2, comma 2. And this is 0, comma 0. Right, so this is Q and this is O. Good. Now, can you guys tell me that, yeah. So for this line, we have to calculate the electric or the work done. So work done would be simply minus Q E dot dr. Now we are moving in 2 dimensions. So dr would be dx I hat and then dy j hat. Right. So this is the case. Now, can you guys tell me that this is Q and this is, what was this electric field? So x plus 2y. And then I hat plus 2x j hat. And then we have dxi plus dy j. So both the integrals are there. Now, if we solve this thing, right, so this would be minus Q, and this is from Q to O. Right, so this is Q, and the first thing would be x plus 2y dx integral from Q to O, and then the next one would be 2x dy integral from Q to O. Now we are in a mix, right? We are in a trouble. So you know that this y and this x, these are two different variables, right, guys? Right.
Yes, sir.
So if I want to integrate, let's say, function of y with respect to dx, is this possible?
No.
This is not possible, right? So somehow we have to change this y. If I make this y, right? If I write this y in such a way that this becomes a function of x. So will it solve this problem, this integral?
Yeah.
Yes. So this can solve the integral, right? Now, if you look at this diagram tells us that how we can change y. Yes? Yes, what did you say? Yes? Whatever is coming into your mind, please tell me. This is what? You are correct. This is what? This is a straight line, y equals to mx plus c, right? Right, guys? Right, everyone? Yes.
Yes, sir.
Yeah. Where m is the slope, this is slope, and this is the intercept. Can you guys tell me what is the intercept in this case? What is the intercept in this case? It's 0, right? So because it is cutting the y-axis at this point, so it is 0. C is 0. Now we have to find out the slope. So slope is how much? That is y2 minus y1 divided by x2 minus x1. This is the slope. So y2 is 2 minus 0 divided by x2 minus x1, that is 2 minus 0, right? So this is 1. So slope is 1, right? So this thing, this equation is simply y equals to x. Clear?
Yes.
Yeah. So we just write this equation as y equals to x. We write minus q, and this is q to 0. This is x plus 2x dx, and then this is q to 0, and this is 2x, and dy I can write simply as dx, right? So this is dx. Right, so how much is this thing? So this is minus q, and then this is x plus 2x and 2x. All these are same integrals. So 5x dx, and we are going from q, which is 2, to this 0, right? So how much is this thing? This is minus q, and this is 5 is taken outside, x squared by 2, right? From 2 to 0. So this would be minus 5q by 2, and then x square is how much? 0 square minus 2 square. Right, so this is minus 5, and then q is how much? Q is minus 10 microcoulomb divided by 2, and then this is minus 4. So this thing and this thing cancels out, right? So we have 5 to the 10 into 10 minus 100, and 10 to the power minus 6 joules. That is the work done from Q to O. Is this part clear, guys? Is it clear? Yeah. So now you see that this is 80, this is 20, and this is 100. Now, if we calculate the total work done, right? Total work done would be how much? So total work done, we WOP plus WPQ and then WQO. So this is 20 into 10 to the power minus 6 joules plus 80 into 10 to the power minus 6 joules. And this is minus 100 into 10 to the power minus 6 joules. So this is 100 into 10 to the power minus 6 minus 100 into 10 to the power minus 6. Right. So both cancels, and total work done is 0. So you guys have could have identified that this is a conservative force, right? So this is work is done due to the conservative force, And the work done in a closed loop for a conservative force is 0. So we got that thing right. Is this question clear to you guys?
Yes,
Yeah.
sir.
Yeah. And did you do this question at in Amna ma'am's class?
No.
Oh, okay, then please write this one down, right? So only the third part, Q to O, that part was tricky, but yeah, all the rest things are very easy. Please note it down, and then we'll do the next question. Yeah, whenever you guys want me to scroll down, please tell me. Yeah. Okay. So then please down from here. Let me just zoom out just.
Nuhun.
Done. Then please note down from. Got disconnected. Okay, yeah, Siddhika, you also tell me if you have noted out, right? Yeah, whenever you guys have noted, please tell me. Good guys. Yeah. Yeah. So quickly note this one down, right? Let me erase this thing. Write it down, and whenever you have noted, please tell me. Without doing this much calculation, you guys have just done that in closed loop derivative force work done or total work done is 0. If they only ask the one part that from WP to Q or Q to A, then you have to calculate. But in a closed loop, if they ask, then you just write 0, right? Without any calculation. Yeah, done, guys.
Yeah.
Yeah. Okay, so the next thing that we are going to write, I will just erase this one because this is the next thing that we're doing. Okay, so first let us understand what is the difference between potential and potential difference. So potential difference is, right, we know that work done is simply initial to final, right? That is simply minus Q and E dot dr initial to final. That is the work done, right? Now, the potential difference is simply the work done in bringing a unit charge, right? So the potential difference, V final minus V initial, this is simply work done in bringing a charge, unit charge from initial point to final point and then unit charge, right? So this would be simply minus initial to final E dot dr. Right, this is the potential difference, VFI or VIF, whatever is there, right? So this is I and F E dot dr. This is the potential difference that you guys already know, right? Now, if I place this initial point, right? If I replace this initial point to infinity, right? Then that potential difference would be electric potential. If I am bringing a charge from infinity to a fixed point, that will become electric potential. So if initial point is infinity, right, then this would be infinity to, let's say, some fixed point R, E dot dr. So that is the electric potential, and it is usually denoted as V ohm. Is it clear, guys? Yeah. Again, you see that this is dependent on E, so this can be uniform, and this can be okay. So yeah, one teacher is waiting, so we will